Hi, this is Jake Samad from the class of 2012, and I'm going to be doing problem 48 on page 102. The problem reads, two crates of mass 75 kilograms and 110 kilograms are in contact and at rest on a horizontal surface. A 620 Newton force is exerted on the 75 kilogram crate. If the coefficient of kinetic friction is 0.15, calculate A, the acceleration of the system, and B, the force that each crate exerts on the other. C, repeat with the crates reversed. So, first off, you need to write the variables that you know. You know the mass of the first box, which is 75 kilograms, the mass of the second, which is 110 kilograms. Then you know the force applied on the first box, which is 620 newtons, and then you know the coefficient of kinetic friction, which is 0.15. So, first off, you need to make a free body diagram. And since you know that it's accelerating because it's the coefficient of friction that you're given is kinetic and not static, the force applied, there is going to be an acceleration. So you know it's moving forward, so you have the force applied, and then the kinetic, and then the frictional force, which is lower than the force applied. Then you have normal force and weight. So the first equation that you can make is force applied minus the frictional force equals the force net, because you know it's moving forward due to the force applied, which is 620. Then you know that weight and the normal force are equal, so you can make the N equals W as an equation. So you want to find out the acceleration, so you just simply bring down force applied minus frictional force equals force net. But the frictional force is the actual equation for the frictional force is coefficient of kinetic friction times the normal force. So you can just do a little plugging in. So the force applied is 620 newtons minus, now the coefficient of kinetic friction is 0.15, and since the normal force is equal to the weight, you get mass times gravity, so 180 kilograms, which is the entire system overall, the 75 kilograms plus the 110 kilograms from each box, since it's asking for the acceleration of the entire system, times gravity, which is 9.8 meters per second squared. And you're looking for the acceleration, so force net equals mass times acceleration. So you know the mass, which is 180 kilograms, times the acceleration. So you just bring 180 kilograms under and divide it. So you have that equals acceleration, and then you just do a little plugging and chugging, and you get 1.9 meters per second squared. Okay, so for the next part, for part B, you're trying to figure out with the 75 kilogram crate in front of the 110 kilogram crate, trying to find out the force on each of that the boxes give on each other. So you have the same free body diagram because nothing has changed so far. Same equations: force applied minus frictional force equals force net, and normal force equals the weight. So you just take the same equation: force applied minus frictional force equals force net, and then the frictional force is mu kinetic times N, and N is mg. So you just do a little plugging and chugging. So 620 newtons of the force applied minus 0.15 times 75 kilograms, which is the box that we're measuring right now, times gravity, 9.8 meters per second squared, equals the force net. So in the end, after a little calculating, you get the force net equals 510 newtons. Alright, so for the next portion of this problem, you need to figure out how much this 110 kilogram box is, how much force it's applying onto the 75 kilogram box. Now, we know that the second box, the 110 kilogram box, has a force of friction as well as the new applied force, which is the 510 newtons from the 75 kilogram box. But because of the force of friction, the net force of the 110 kilogram box is going to change by a certain amount. Now, that's because of the force of friction, obviously. So, because the force net is changing on the entire system, because of the second box's frictional force, you can assume that the frictional force is the actual force acting upon the 75 kilogram box's net force. The equation for frictional force equals mu kinetic times N, which is mg. So you just do a little plugging and chugging right there. So frictional force equals 0.15 times 110 kilograms, because we're focusing on the other box at this point, times 9.8 meters per second squared. After a little calculating, you figure that the frictional force is equal to 160 newtons. So for part B, the force that the 75 kilogram box is exerting on the 110 kilogram box is 510 newtons, while the opposite, the force that the 110 kilogram box is exerting on the 75 kilogram box is only 160 newtons. Now, time for part C, where we flip everything. Now, for the first part, for part A, I guess, if you were going to redo it with C, the answer is not going to change, because just because the position has changed doesn't change the mass, which is the main portion of this problem, which you have to plug in. So the actual acceleration of the entire system, because the mass is staying the same, is going to remain 1.9 meters per second squared. However, for the next portion, the portion with the 110 kilograms box and the force it exerts in the 75 kilogram box, and vice versa, it's going to be a little different, but you do use the same approach. So you have force applied minus frictional force, which is mu k times n, which is mass times gravity, equals the force net. Just do a little plugging and chugging, but instead of having 75 kilograms in the mass area, you have 110 kilograms. So after that, you get a force net of 460 newtons. Now that is the force that the 110 kilogram box is exerting on to the 75 kilogram box. Now, we already have figured out that the opposing force that is opposing the 110 kilogram box is the force of friction. So you just do a little plugging in. So 0.15 times 75 kilograms, not 110 kilograms like we had last time because the boxes have switched, times 9.8 meters per second squared, which is gravity, is equal to 110 newtons. So, for part C, the force that the 110 kilogram box is acting upon the 75 kilogram box is 460 newtons, while the force that the 75 kilogram box is exerting on the 110 kilogram box, or the frictional force, is equal to 110 newtons.